Alright, the directions for number 22. Identify which formula you should be using for each of the series. Then compute each series, and it gives you the formulas. In number 22, they give you summation notation. The first thing I need to do is figure out the ratio. Put your finger on the ratio. Remember, the ratio has an exponent. So there's two bases here. This base has an exponent. 2 over 11 is your ratio. If I put 2 11ths into my calculator, you'll know that it is less than 1. And you also know it's less than 1 because 1 is 11 over 11. I know it's a geometric because it has a common ratio. If it's less than 1, it's going to be a finite. And it's going to be a convergent. So I'm going to write down the formula. In order to use the formula, I have to know the G1 value. So to figure out G1, I'm just substituting in I equals 1 into this value. 5 times 2 11ths to the first power. So G1 is equal to 5 over 1 times 2 11ths. And then I can just multiply across. G1 equals 10 over 11. Now I can put that into my value here. So I have 10 over 11 over 1 minus 2 11ths. Remember, how do you make 1 a fraction? In this case, I'm going to multiply by 11 over 11, so S equals 10 11ths. 11 over 11 minus 2 over 11 is 9 over 11. You take that sideways. What happens to the division sign? And you flip it, which gives you what? 10 11ths times. Then we get a sum that is 10 over 9. So in this problem, to review, they give you summation notation. Look for the base. That becomes a ratio. So ratio, it's a geometric infinite because our ratio is less than 1. Sorry, not infinite, it's finite. So because we have a finite, we're going to use the formula. To use the formula, you have to find your G1 value. So take I equals 1, put it in, and then put it into your formula and simplify, and you get a sum to be 10 ninths. Some student asked me, does it have to be a fraction or decimal? This one's better because this is an exact. Decimals are always rounding, so it's not good enough.